Welcome to another Ziva Math video. In this video, we are going to solve one-step inequalities, which you'll find follow the same process as solving one-step equations. The first four problems will focus on the steps and on how to graph inequalities on the number line. There's only one rule you'll need to remember with inequalities when working with negative numbers, and that will be the focus of the last three examples in the video, so be sure you don't skip this part. Let's get started on our examples. For our first example, we have x minus 3 is less than 6. And we just said in the introduction that you can treat these just like one-step equations. So you could pretend in your head that that inequality sign is actually an equal sign. Because with an equation, you would tell me that we need to isolate x, and then whatever we do to the left-hand side, we're going to do to the right-hand side. Which means if you want to box x and put the line down the center of your inequality, so that you make sure whatever you do on the left, you do on the right, go ahead and do that. So then on the left, we have x minus 3. And if we want to isolate x and get it all by itself, our inverse operation is going to be to add. And we're going to add 3. If I add 3 to the left-hand side, I need to add 3 to the right-hand side of my equation. So then on the left, we haven't done anything to x, so x remains in my problem exactly how it is. I have negative 3 plus 3, which is 0. So I have x plus 0 on the left. On the right-hand side, I have 6 plus 3, which is 9. And our inequality sign remains the same. We haven't done anything in this problem to require us to flip it, so it's still a less than sign. Now we need to simplify, so x plus 0 is x. In simplifying, again, we didn't do anything to require us to flip that inequality, and then we didn't do anything to the 9. So our solution is x less than 9. Now, one thing I want you to make note of here is this line, x plus 0 is less than 9. You don't actually need that in your problem. If it makes you feel more comfortable to show every step and include that line, go ahead and continue doing so. But in the future, I'm going to leave that line out. So if we did negative 3 plus 3, I'm not going to show the 0 anymore. So we have x is less than 9, and a lot of us are going to be required to show this in a number line. So notice on 9, I put an open circle. We don't have x equals 9, so we can't use that closed circle. We have to use an open circle because x can be right up until 9, but it can't be 9. Then I drew an arrow in, and this arrow is going to the left because we don't have just one solution, we have many solutions. Any value of x that's less than 9 is part of the answer set for this problem. So whether that's x is 0, x is 8, x is 8.9999, anything up until 9 can be part of your answer set. So we're going to show this with an open circle at 9 and an arrow going to the left. For our second problem, we have 4m greater than or equal to 24. So again, if you want to think about these as being equations, you're going to be working these one-step inequalities the same way, where we're going to want to isolate our variable m, and whatever we do on the left, we're going to do on the right. So if you want to box your variable and draw your line through your inequality sign to get set up, go ahead and do so. So we have 4 times m, which means our inverse is going to be dividing, and we're going to divide by 4 because that's what we multiplied m by. If I divide by 4 on the left, I need to divide by 4 on the right. So on the left, my 4's through the division process will simplify out, leaving me with just m on the left. And then on the right, I have 24 divided by 4, which is 6. And in my steps, I did nothing to require me to flip that inequality sign, so it's going to remain the greater than or equal sign. So I have m is greater than or equal to 6. And if you are needing to graph this on the number line, we're going to put a closed-in circle on 6 this time because our solution was m is greater than or equal to 6. 6 is part of our solution set, so we're going to use the closed-in circle this time. Then we have m is greater than or equal to 6. So our solution set includes all of the numbers greater than 6. So you're going to add the line going to the right, showing that your solution set includes all of the numbers greater than 6. For our next example, we have 2 less than or equal to f divided by 5. Notice I put our variable on the right-hand side this time, but it's not going to change any of your steps. We still want to get that variable by itself, the f by itself, and we're going to take those same steps to do so. We have f divided by 5, which means our inverse operation is going to be to multiply by 5. If I multiply by 5 on the right-hand side, I'll need to multiply by 5 on the left-hand side. So then on the right-hand side, through the multiplication steps, our 5s are going to simplify out, leaving us with just our variable f. And on the left-hand side, we'll have 5 times 2. 5 times 2 is 10. And I haven't done any steps that would make me need to flip my inequality sign. So I have 10 is less than or equal to f. And here's where you need to be careful when you go to graph this inequality on your number line, because your variable is on the right-hand side this time. We need to think about what this inequality means. First, though, we have less than or equal to 10, which means 10 is part of your answer set. So we're going to be using a closed-in circle or a point at 10. So our inequality states that 10 is less than or equal to f, that 10 is less than or equal to the numbers that are included as part of our answer set. So 10 is smaller than those numbers. So our answer set is everything that is 10 or greater, which means you're adding that line going towards the right on your number line to signify that numbers 10 or greater are part of your answer set. For our next example, we have x plus 6 greater than negative 2. And again, even when you see negative signs in our problem, we're going to work our steps to solve our inequality the same way. So we're going to want to isolate our x, and we're going to want to make sure that whatever we do on the left-hand side, we have to do on the right-hand side. Now, we did say in the introduction, if you have negatives, you need to be careful because there is a new rule you need to pay attention to. That doesn't apply to this problem. We're just going to practice solving with the negative in it. So I had x plus 6, which means my inverse is to subtract 6. If I subtract 6 on the left, I'll need to subtract 6 on the right, leaving me with x on the left because 6 minus 6 is 0. And that's what isolated our x on the left. Then I have negative 2 minus 6. I can think about that as adding integers with the same sign. So 6 plus 2 is 8, and I'm going to keep the negative sign. And again, as I just said, we didn't do anything here in this particular problem that would cause us to need to flip that inequality sign. So we still have the greater than sign. So I have x is greater than negative 8. And I'm going to graph this by putting an open circle at negative 8 because x is greater than negative 8. It doesn't include the negative 8. It does, however, include every number that's bigger than negative 8, which is why our line goes to the right. In the introduction to the video, we stated that there was one rule that you need to remember when working with inequalities, and that was related to when your problems have integers in them. And that's what we're going to look at in these next 3 examples. So the first example, I have negative 3m less than or equal to 9. And I still want to get my variable m by itself, and I'm going to do that by dividing both sides by negative 3. So on the left-hand side, my negative 3's will simplify out, leaving me with my variable m. And on the right-hand side, I have 9 divided by negative 3. A positive divided by a negative is a negative, and 9 divided by 3 is 3. Now, what you need to notice here is that in our step, we divided the left-hand side and the right-hand side by negative 3. If I divide both sides by a negative, then I have to flip my inequality sign. So instead of a less than sign, I'm going to have the greater than or equal than sign. So my final answer is m is greater than or equal to -3. So again, if your step is to divide the left and the right by a negative, then you must flip your inequality sign. So looking at our second example, we have 5x less than or equal to -15. And to isolate our variable x, we're going to divide both sides by 5. So on the left-hand side, those 5s will simplify out, leaving me with my variable x. And on the right-hand side, I have -15 divided by 5. Well, a negative divided by a positive is a negative. 15 divided by 5 is 3. Now, in our step where we divided both sides, I divided both sides by a positive number. So in this example, I'm not going to flip the inequality sign. It's going to stay less than or equal. So I'll have x is less than or equal to -3. Yes, I divided a -15 by 5, but in my step where I divided the left-hand side and the right-hand side, I divided it by a +5, so my inequality sign remains the same. In my third example, I have v divided by -2 is greater than 6, so my inverse operation is to multiply, and I'm going to be multiplying by the -2 because I want to get v all by itself. My -2's will simplify out, leaving me with v on the left. On the right, I have a positive times a negative, which is a negative, and 6 times 2 is 12. In this example, I multiplied both sides by a negative number. And because I multiplied both sides by a negative number, I'll need to flip my inequality sign. So my answer will be v is less than -12. So the rule that we talked about that you need to pay attention to for inequalities is if you divide, like we did on the first example on this screen, or multiply, like we did on the third example on this screen, both sides of the equation by a negative. So this is the step that you're taking in your problem. Then you must flip the direction of your inequality sign. So again, if you divide or multiply both sides of the equation by a negative, then you must flip the direction of your inequality sign. Thank you for watching. Be sure to like this video and subscribe to Ziva Math for more videos.